Welcome back everyone, Patrick here, moving on to another question dealing with expanding and simplifying expressions. So we have a bunch of expressions here we're multiplying. So starting off with part A, we got 5 times x minus 2 times x plus 4. So this one here, notice that instead of having just 2 terms that are multiplying, we're actually now multiplying 3 terms. And there's different ways to do this, because if you're multiplying more than 2 terms, it doesn't matter which order you go in. So for example, if we have to make it more simple, let's say we got 3 times 4 times 5. Well, it doesn't matter if we go 3 times 4 first, so that would be 12 times 5, and then that would give us 60. But we can also do 4 times 5, so we could do 3 times 20, and that also gives us 60. Or we could do 3 times 5, which would give us 15, and then we're still got the 4 left, and that would also give us 60. So if you're multiplying the order, it doesn't matter. Now, personally, what I do is if I get something like this, if I have like a single expression and then I have binomials or even trinomials that are multiplying, in this case it's 2 terms in each bracket that are multiplying, I do the tough stuff first. So I multiply these 2 brackets first and I leave the 5 on the outside, right? You don't have to do that. So actually with this particular question, I'll show you 2 different ways to do it and how you get the same answer. And then for the rest of these, I'm just going to do it one way. And whichever way you want to do it, you can do it whichever way. Just make sure that you're getting the same answers that I am getting. So what I'm going to do is I'm going to multiply this by this first. So we're going to keep the 5 on the outside, and then let's put a big square bracket to represent the product of these. So we'll have x times x, which gives us x squared. We'll have x times positive 4, which gives us positive 4x. Negative 2 times x gives us minus 2x. And then negative 2 times 4 would give us minus 8, like that. Right, so this big square bracket represents the multiplication of these 2 brackets. And then from here, what I like to do is I like to simplify this square bracket first before distributing the 5 inside the bracket. You could also distribute the 5 at this point, so I'll actually show you that as well later. You could distribute the 5 at this point and then simplify, but then you're just going to be dealing with larger numbers. I recommend just simplifying this first and then distributing the 5 after. So notice that the 4x minus 2x, that simplifies to positive 2x. Now we've got the minus 8. And now I would distribute the 5. So multiplying the 5 by everything, 5 times x squared gives us 5x squared, 5 times 2x gives us 10x, then 5 times negative 8 gives us minus 40, like that. Then you can't simplify any like terms here. So that right there ends up being the answer. Now, what if we distributed the 5 at this point? Well, we could do that too. So we'd have 5 times x squared, which gives us 5x squared. 5 times 4x, positive 4x would give us 20x. 5 times negative 2x would give us minus 10x. 5 times negative 8 would give us minus 40. And then these like terms, 20 minus 10 gives us positive 10x minus 40. So notice we get the same answer if we distribute the 5 at that point. Again, I recommend just simplifying first and then distributing, because then you're not dealing with as large of numbers, right? Here you got 20x minus 10x. Here you just got 4x minus 2x. Not as big of a deal here, but as the numbers get larger, it can start getting more complex. All right, so that's one way to do it. Now, what if we switched up the order of our multiplication from the beginning? So let's say instead of multiplying these 2, let's say we multiply the 5 and the x minus 2. So let's say we multiply these 2 over here. Well, 5 times x minus 2, we just distribute the 5 in, so we'd end up with 5x minus 10, like that, right? 5 times x is 5x. 5 times negative 2 gives us minus 10. And then we still have this x plus 4 to multiply at the end. And then you can just FOIL this out now, right? So we'd have 5x times x, which gives us 5x squared. 5x times 4 would give us 20x. Negative 10 times x would give us minus 10x. Negative 10 times positive 4 would give us minus 40. And so notice we end up, these are like terms, we end up with that same solution, right? So whichever order you go with, just make sure you're getting the correct answers. You could have also multiplied the 5 and the x plus 4. You'd get what? 5x plus 20. Then you could do 5x plus 20 times x minus 2. You should end up with the same value over here. Okay, so multiple ways to do these kinds of questions where there's more than 2 terms. Obviously, if there's only 2 terms, those are the only 2 terms you can multiply each other by. But if there's more than 2 terms, then the order and everything is multiplying, then the order is not as important. All right, so let me actually write out, it was 10x, right? Yeah, minus 40. So that was the answer for part A. Now with part B, I'm going to do it the way that I mentioned before. So the negative 3 I keep on the outside, then I'm going to multiply these 2 brackets. So we'll have x times x, which gives us x squared, x times negative 1, which gives us minus x, 6 times x gives us positive 6x, and then 6 times negative 1 would give us minus 6, like that. And then from here, like terms, negative 1 plus 6 would give us positive 5. And then we got the minus 6 here. Give me a sec. Yes. Looks all good to me. And then from here, then we could distribute that negative 3 inside the bracket. So we end up with negative 3x squared minus 15x plus 18. Right? Negative 3 times negative 6 gives us a positive 18, like that. So that ends up being the final answer. And again, if you want to practice the other ways, it would just help with practicing your algebra. Feel free to do that. Just make sure that you are getting this same final answer. And then part C, we have negative times 2x minus 3 times 3x plus 2. So here, if you just have a negative in front, it's like a negative 1 that's in front right there. But same thing, it's like a negative 3 here, negative 1. We're going to multiply these 2 brackets first. So we got the negative 1 on the outside, and then the square bracket's going to be these multiplying. So 2x times 3x gives us 6x squared. 2x times positive 2 would give us positive 4x. Negative 3 times 3x would give us minus 9x. And then we got negative 3 times 2 would give us minus 6, like that. And then usually I just like to quickly double check my work. Yeah, it looks all good to me. And then from here, what you want to do is you want to simplify that square bracket. These 2 are like terms. 4 minus 9 would give us minus 5. Minus 6. Like that. And then the negative 1, we could just distribute. Basically, it keeps the same coefficients, just changes the signs. So negative 1 times positive 6 would give us negative 6. Negative, negative turns into a positive. Negative, negative turns into a positive as well, like that. Okay, so this here ends up being the final answer for that. So let's write that over here, negative 6x squared plus 5x plus 6. Again, if you want to practice the other ways, feel free to do so. And then finally, part D. So let's actually start this down here. So got the 2x. Now here, just be careful. We got multiple variables. And then we have a variable here. So we got the 2x on the outside. I'm going to keep that on the outside for now. I'm going to multiply these over here. So we'll have 3x times 7x would give us 21x squared. 3x times 8y would give us 24xy. 5y times 7x would give us positive 35 xy as well. You end up with yx, but again, I recommend putting everything in alphabetical order if you're mixing variables, just so you could notice the like terms a lot easier. And then we'll have 5y times 8y, which would give us positive 40 y squared, like that. So 21x squared, 24xy, 35xy, and then 40y squared, like that. Then from here, notice that this and this are like terms. So continuing this over here, we still got the 2x on the outside, 21x squared. These two are like terms, so 24 plus 35 would give us what, 59? xy like that, plus the 40 y squared, like that. Okay, and then from here, what we got to do is we got to take this 2x and distribute it into the bracket. So this one, not only are we working with bigger numbers here, but we also have this variable. So just again, be very careful. You know what? Let's actually write this out. For this one, I'm going to write all of it out. So we'll have 2x times 21x squared plus 2x times 59 xy, and then we'll have 2x times 40y squared, like that. Usually when it starts getting complex like this, sometimes I just like to write it fully out. It does take a little longer, but it decreases your chances of making a mistake without doing too much mental algebra. So here, starting with this, 2 times 21, 42, and then x times x squared gives us x to the power of 3. 2 times 59 would give us, what would that be? That'd be 118, right? And then from here, x times xy, notice we can multiply the x's, that would become x squared, and then there's a y still remaining. Right, on the side here, x times xy, we can multiply the x's, add the exponents, and then the y is still there. That's how we get that x squared y. And then 2 times 40 would give us positive 80. X times y squared, we can't combine those because they're different bases. So we end up with that right there. And then just be careful, there's no like terms here. X squared y, x y squared, those are different kinds of terms because the exponents are different. They both contain the xy, but here we have x to the 2, y to the 1. Here we have x to the 1, y to the 2. Now if this was x squared y over here, then we can add these. Then we can net them out because it would be like terms, right? Like terms, just as a quick review from previous units, from grade 9 even, from a previous grade, the like terms, they always have to have the same combination of exponents. So the same base and the same exponent. So we have the same basis here, but the exponents are different. So those are not like terms. All right, so this one was fairly complex versus the other ones. Not only bigger numbers, but you're also dealing with multiple variables and then an additional variable in front over here. But the final answer for this ends up being that.